Welcome. In this video, we're going to sketch the first and second derivative of this curve here, h of x. And I'm going to do that by layering one graph above another. So right below, I begin by going ahead and sketching my y-axis so it lines up, then my x-axis. There we are. Now I'm going to identify all the spots where I have a horizontal tangent line, and that's in 3 places. So the tangent line here, here, and here are all horizontal. And on those spots, I'm going to go ahead and trace out a dotted line all the way to the next axis. I know that is where my first derivative will intersect the x-axis. Since the derivative of the function there is 0, the slope of the tangent line is 0. That tells me the derivative function has to intersect the x-axis there. Now, I do want to point out something here. Notice that as we get more positive, the slope is positive, it actually becomes completely vertical here. And that is something special, and I'm going to identify that with this pink dotted line. When that occurs, we actually have asymptotes for the first derivative. I know that the slope is positive on this side and positive on this side, so I know my derivative is just kind of shooting off and growing here. And now what's happening close to this point? Well, the derivative is still positive, but it's less positive. So that means it's lower down since this is less positive and more positive. So I need a point here. There we go. Similarly on this side, it becomes less positive the closer we get to that horizontal tangent line. Now between this and this max and this min, the slope is negative. It's not very negative here and also not very negative, but it's more negative here. So right about there will probably be the lowest point. There we are. And then the slope remains positive after this, so I'm going to go ahead and do that. I did miss this side here. This side, the slope is very negative here and less negative. So the less negative point is here, and the more negative point is here. There we are. And this is y equals h prime of x. Okay, so now let's go ahead and sketch the second derivative. Again, I started by sketching the x-axis and the y-axis. Now I'm going to look for any points where I have a maximum or minimum. And again, these are ones that look like either cups or inverted cups. And so I have one here, so I'm going to go ahead and sketch that out. Now this asymptote is going to remain the same because as you can see, the tangent line here is very, very positive, and I'm not going to say what the tangent line is doing here yet, but maybe you get the idea. I want to start by going ahead and sketching that point where my second derivative, this is y equals h double prime of x, crosses the x-axis. So now let's start off, let's say to the right here. What's going on? Well, to the right here, the slope is just positive, so I'm going to go ahead and sketch this above the x-axis. What about to the left? Well, I am negative here. Notice that this is all negative. This is less negative, so closer to the x-axis. This is more negative, so further away. So it's going to look like this. Now, what about this portion of this derivative? It's never going to cross the x-axis, so it has to be all up here or all down here. Let's figure out where it's going to be. If its slope is positive, it'll be above the x-axis. If the slope is negative, it will be below the x-axis. So here we have a very positive slope, slightly less positive, going to more positive, more positive, more positive, more positive. And it looks like it gets its least positive right around here. So let's go ahead and sketch that in the correct color. There we are. And it's getting more positive in both directions. And there you are. I still did not use the correct color, so let me go ahead and fix that. To recap, here's the original function. and its first derivative. And here's the first derivative compared to the second derivative. I'm hoping this new knowledge heralded happiness in your heart.